Let's now use our factoring skills to solve equations, specifically quadratic equations. So first, I'd like to share with you what a quadratic equation is. This is an example of one, a quadratic equation. Look here, we have a 2x squared, that's the important piece right here, plus a 3x minus a constant, or plus a constant, equals 0. So first of all, these are equations, so they have an equal sign. And we're looking to find a value for x, or maybe a couple values for x, that work in that equation. We say that a quadratic equation is something in general form is something that has a coefficient in front of the x squared term where that cannot equal 0. This value cannot equal 0 because 0 times x squared is nothing. And you lose your x squared term then if a is equal to 0. And you don't have what's called a quadratic. A quadratic equation has at most, in terms of degree, an x squared term, and it has to have the x squared term. It doesn't have to have the x term, it doesn't have to have the constant, but it has to have this. So this could be 0x. At any rate, here's ax squared plus bx plus c equals a constant. So that's what a quadratic equation looks like. From here, so now that we've established that, we're going to take a look at a property or a rule that we use to solve these. And it's called the principle of zero products. I'm going to write that down. Principle of zero products. It says that if you take two or more things and multiply them together, it could be more, but we'll only have two for the most part. Two or more things, and if they are equal to 0, for this statement to be true, either A has got to be equal to 0, so that 0 times B is 0, or, very important, or B has got to be equal to 0, so that A times 0 is 0, or this can't be solved. So it's called the principle of zero products. It says that one or the other of the factors has got to be equal to 0. So I'm going to take a factored form of a trinomial. This is a factored form. So I already had a trinomial with an x squared term, and I factored the left side of that into this. This is my a, if you will, right here. It's a times, this is my b right here. And one or the other of these has got to be equal to 0. And so I'm going to let x minus 2, I'm going to set it equal to 0. And I'm going to add 2 to both sides to find out that one of the solutions for x is 2. And then right here, I'm going to set the x plus 5 equal to 0. And I'm going to solve for x by subtracting 5 from both sides and finding out that the other solution for x is equal to a negative 5. I can and should always check these and see if they work. So my original problem is right here. It reads x minus 2 times x plus 5 equals 0. And so if I were to take that answer right there and put it in for x in both spots, here I'd have 2 minus 2, oh that's 0, times 2 plus 5. So does 0 times 7 equals 0? That kind of illustrates that one or the other has got to be equal to 0. This one or this one. Let's do this check over here. So if we take the original problem, the x minus 2 times the x plus 5, and we put in this answer, so tell me, a negative 5 minus 2, so I put in for x a negative 5, that's a negative 7. And here, a negative 5 plus 5, oh, that's 0. So a negative 7 times 0, does that equal 0? It sure does. And you can also again see that this right side, when x is a negative 5, is going to be what's equal to 0. Let's do a problem where it's not given to us in factored form. So let's go with, I guess I'm going to get rid of this here too. Let's say that I had x squared minus x minus 6 is equal to 0. And I wanted to solve that for x. What I would do is I'd come over here and I'd say, well, geez, I want to factor this. So I want two numbers whose product is a negative 6, and they have to add to be the coefficient of the x term, which in this case is a negative 1. Let's see. First thing that comes to mind is 3 times 2. And then I'm going to step back for a minute and say to myself, well, the product has to be a negative number, so one of those has to have a negative sign. I want these two numbers to add to be a negative number, so maybe I better put the bigger number and make it negative so that a negative 3 plus 2 will equal that negative 1. And so now I'm going to go ahead and factor. This is the easy trinomial factor. It's got an a value of 1, so I get to just stick those numbers, the negative 3 and the positive 2, into the binomial, and I know I have the factored form. And then now the zero product rule allows me to take this factor and set it equal to 0 and find out that 3 is one of my answers to this problem. And then over here, the zero product rule lets me set this equal to 0, and I'll subtract 2 from both sides, and I find out a negative 2 is one of the solutions to this equation. This original equation looked like this. If I were to check this, I'm going to come over here and check each of these in that equation. So I'm going to take x and square it. I'm going to use 3 first. So 3 squared minus 1 times x, or minus just x, minus 6, and I wonder if that equals 0. So I have 9 minus 3 minus 6. I'm going to just be the devil's advocate and work left to right. So 9 minus 3 is 6. Minus 6, does that equal 0? Sure does. Let's go over here and check the negative 2. So the original problem read x squared minus x minus 6 equals 0. And let's put in a negative 2 anywhere we see x. Please remember, when you substitute a number in for a variable, you should put it in parentheses. So if it's a negative number being squared, you got to put that in parentheses so that you will realize that that's equal to 4, a positive 4. And then look, bring this minus sign down and then substitute in for x a negative 2. And then let's go ahead and call this 4. And when you subtract a negative number, you add a positive. And then finally 4 plus 2 is 6. And 6 minus 6 is indeed 0. Okay, so we found out that both of those solutions work. I think I'll stop this segment right here, and we'll come back to doing some more solving equations via factoring in our next video number 2 for this topic.